In this video, I'll talk about 2.5, measure of precision. In 2.3, we learned how to measure central tendency of a data set. And in 2.4, we learned how to measure variation of a data set. They both are quantitative data. And in this section, we'll learn how to measure precision of each data entry in data set, also quantitative, not for categorical. Let's first look at quartiles. Quartiles approximately divide an ordered data set into 4 equal parts. So there are 3 quartiles, Q1, Q2, and Q3. Q1 because Q1 divides the data set into 2 equal pieces, so that's just median. Example. We first need to sort data from smallest to the largest. So you can see from 6 to 104, and then there are 15 numbers, so find the Q2 first. Although we have Q1, Q2, Q3, but we actually need to find the Q2 first, the median first. So for 15 numbers, the 8th number is the median, Q2, which is 18, and then Q2 divides data into 2 halves, the lower half and the upper half. The lower half, from 6 to 17, there are 7 numbers. Upper half, from 18 to 104, also 7 numbers. And Q1 is the median of the first 7 numbers, and the Q3 is the median of the last 7 numbers. So Q1 is 10 and Q3 is 31. So that's how do we find all 3 quartiles. So actually there are 3 medians. Q2 is the median of the whole data set, and Q1 is the median of the first half, the lower half, and Q3 is the median of the upper half. We can use StatCrunch to find quartiles. You just copy numbers into StatCrunch. Okay, I'll show you. If you click Stats, Summary Stats, Columns, and let's say if I use variable 1 as example, then you can find Q1, Q3, Q2 as a median. So it's very easy. The interquartile range, it's the difference between Q3 and the Q1. That will give you the middle 50% of data. So if we use these 3 quartiles with the minimum and the maximum, we can make a box plot. Well, the box actually is from Q1 to Q3 with the Q2, draw a line on the Q2. So this box gives the middle 50% data and the minimum, maximum. So from minimum to Q1, this is 25%, and from Q3 to maximum is also 25%. So it's called a box and the whisker plot. So here's the example, and as you can see, 104 is an outlier. So from here to here, see the tail is quite long. It's easy to see the shape of box plot. It's skewed to the right. The right whisker is much longer than the left whisker. We can use StatCrunch to make a box plot easily. So if you copy data, and you can just click Graph and then box plot. So if I say I use variable 1 as example, and then I can just click Compute. Okay, so here's my box plot, where my 65 is the outlier. If you rotate your box plot clockwise, you'll find the shape of the box plot easily. So this is a right skewed. besides quartiles, we have other measurement to for precision, like percentiles. And percentiles divide data into 100 equal parts. We have decimal divide into 10 equal parts. Just for your knowledge. Now, how do we interpret percentiles? If you have an ogive, remember from section 2.2 we learned some graphs, a histogram, frequency polygon, and ogive. Now this is based on the cumulative frequency and the upper class limit. So if you're given a graph like this, what test score represents the 62nd percentile? And then you can just look at here. This is if you use the cumulative relative frequency, this will be percentiles, and then you can find 62 is somewhere here, so that score will be 1600 or less. So that's how you get percentile. Means their 60% numbers are less than or equal to this value.